Hi everyone, this is Edwin Hernandez and this is Faraday's Law Lab 5. So in introduction, we're trying to find Faraday's Law from following magnets in an aluminum cylinder. Some principles that we use were the abuse of art law, Newton's second, third laws, and Faraday's Law. As we saw, some of the data that we got was that in real life, the drop was 1.23 seconds, and then the model it's 1.21 seconds, so I'm pretty close. So the setup was that we dropped the magnet down from this aluminum cylinder and we recorded it and saw using our cameras. We found like the timings. So the dimensions of the tube is that the length of it is 0.3 meters or approximately 30 centimeters. Width of it is 0.006 meters. The outer and inner radii is 0.026 meters and our inner is 0.02 meters. Our magnet mass is 0.025 kilograms, and here are the time, which is from the past slide. Some of the thoughts, so we have, so why can't we use a ferrous tube? It contains iron, which magnetic fields can induce a current, which interferes with our data. It will just slow it down a little bit better, a lot slower. So what if it was dropped in free space rather than the tube? The magnet experiences some resistance in the tube, which slows down the magnet, and if it's dropped in free space, the only thing that will be resisted and that will resist it will be uh, air drag. So it'll be a little bit faster than in the tube. So here's my glow script. As you can see, it's split in four parts. Some pretty important areas is it's pretty much in this area, which are the flux, the currents, and how everything just the F net, the F gravity, and all that. Here's some of the results. So we see there's a decrease in velocity, there's a constant velocity when it's going through the tube, and just when it comes out, there's a very tall spike in velocity. Hello, this is the video that I have here, which shows the graph right here, and also the tube, and I show here the how it is. And so you can see the video, the seconds it took. Now some final questions. What if the resistivity of the conductor were reduced and as close as possible to zero, or dynamics of the falling magnet change? So the Ohm's law is V equals I R. V equals I R. I is the inductance, R is the resistivity, and also V is the voltage. So if we just divide out R, the resistivity, we're left with I equals V R. So we're left with that, and if our resistivity, which is our R, so if our resistivity of the conductor is R and it's going closer and closer to zero, our I will just shoot up to infinity. So by that logic, the time it will take for the magnet to fall out will be very long or infinitely long. It will never leave the tube. So if there were holes or slots cut into the tube, will have the effect on the ring currents in the model. So it will create a decrease in area in the magnetic, in where the magnetic fields can induce a current, which means the magnet will fall down faster. It won't have as many rings per se. Thank you and have a nice day.